In this section here, we're going to be going over absolute extrema. Now let's first read this theorem here. The extreme value theorem. If f is a continuous on a closed interval AB, then f has both a minimum and a maximum on the interval. So the key here is we want to make sure that our function is continuous. In the examples that is continuous on this interval here, in the examples that I'm going to give, they're all going to be continuous between A and B. Well, let's get started. Alright, so we're going to start off with something really simple, and I'm going to let my function, first off, let's go with black. We're going to define f of x to be x, and we're going to be on the interval between -1 and 1. Alright, so step 1. I'm going to first take the derivative of this function, and the derivative is just clearly 1. And then what you want to do is set it equal to 0 and solve for x. Well, in this particular case, we don't have any critical numbers. Okay, so it wouldn't make sense for us to set this set 1 equal to 0. Okay, so we're going to stop right there because there are no critical numbers. And the critical numbers are the numbers that could possibly indicate where there's a minimum or a maximum. Alright, step 2. Once I've found my critical numbers, which there are no critical numbers here, then what I'm going to want to do is just simply take our endpoints here and plug them into the function. Right, so f of -1 is -1, and f of 1 is easy enough, is 1. Okay, so as you can see here, our minimum is going to occur here. This is the smaller value of the two y values, and this one here is going to be a maximum, and we might want to write that as a point, and that would be right, the minimum point occurs at -1, -1, and the maximum occurs at 1, 1. Now let me see if I can kind of sketch this out so you can get an idea of what we're doing here. So I'm going to let our function be green. Why not? Okay, so -1 is here on the x-axis, and we'll say 1 is here. So when we plug -1 in, we're looking at this point on the graph. We plug 1 in, we're looking at that guy right there, right? So as you can see, we're looking at the y values here, and the smallest y value out on this graph is of course occurring at -1, and the largest y value is occurring at our y value is 1 here. Alright, so you can clearly see this is going to be the absolute maximum point and the absolute minimum point on the graph. Alright, I think we'll just leave it at that. So let's work some ones that have actually got some critical numbers in them. Okay, in the last problem we really didn't need calculus to find the absolute extrema. But in this problem here we're going to need to use some calculus. So we're going to work with h of x is equal to x squared, and we're on an interval, I should say a closed interval, -1 and 2. Alright, now first thing we're going to do is we're going to find the derivative. So h prime of x is equal to the derivative of x squared is 2x. And then we're going to set this equal to 0 We're going to find those critical numbers where there's a possible max or a min. So in this equation here, we can see that x will be a solution, or 0 will be a solution to this equation. So this is one of our critical numbers here. I'll just label it with this CN for critical numbers. So now what we want to do is we want to take this 0 and plug it back into our original up here. And as we can see, we get 0 out. So h of 0 is equal to 0. Alright, now that we've done that, what we're going to do now is plug negative 1 into h of x. So negative 1 is equal to negative 1 squared, which is 1, and then we're going to plug in the other one, h of 2, and that's 2 squared, which is 4. So h of 2 is equal to 4. So between these numbers, h of 0 is equal to 0. So between these are the numbers here that we're looking at. Alright. So as you can see that a maximum is occurring here because this is our largest number of the three, and then a minimum, the smallest number is our 0 here. So easy enough. We're going to say that the absolute, and I'm just going to abbreviate as ABS, the absolute max, and I'm going to label this as the point here. Okay, so the absolute maximum is occurring at 2, 4, the point 2, 4 on the graph, and the absolute minimum is occurring at 0, 0. Let's see if I can pull a graph up on, and so we can take a look at this. Okay, so here's a graph. Now we're between negative 1, which is here on the x-axis. So here's our corresponding y value. We're between negative 1 and 2, so 1, 2. And there's our other y value here. This is the actual other point on the graph. So between here and here, now let's look at the smallest y value on this interval of, well, if we follow the graph down, you can clearly see that right here is going to be our smallest y value. Of all the y values on this graph, this right here is going to be the smallest. So at the point 0, 0, okay, and then up here, this will be the maximum y value at the point 2, 4. Alright, so it's kind of easy when you just look at a graph and see what we're looking at. Looking at the max and the min. Alright. Alright. Let's take a look at this guy here. We got f of x is equal to negative x squared plus 3x. So hopefully you know how to take derivatives. I will have a link taking you straight to how to take derivatives. I worked quite a few examples, but anyway, so the first thing I said, it doesn't matter how we get to the end here, but I guess I better write our interval. We're on a closed interval between 0 and 3. I've been saying take the derivative first, but it doesn't matter. You can plug your endpoints in first, get those numbers. You know, what difference does it make? But we'll just take the derivative first. So we got f prime of x is equal to negative 2x plus 3, and then we want to get those critical numbers, and so we set the derivative equal to 0. Right? This is where the slope, if we were looking at a graph where the tangent line is 0, get the solution to this equation, find the solutions. We're going to plug, let's see, take negative 3 over, divide by negative 2, right? Hopefully you can solve for x in this problem at this point in your career. So x is equal to 3 halves. So we got one critical number. Now what we want to do is take this 3 halves, that negative over negative is going to cancel out. And want to go ahead and take the 3 halves and plug it in to our function up here. So we got 3/2 squared plus 3 times 3/2. So we're dealing with some fractions here. Hopefully that doesn't scare you off. I'm just going to go ahead and skip all the fraction nonsense, and I came up with 9/4. Alright, so f of 3/2 is equal to 9/4. Hopefully you know how to get there. I'm not going to get into all that. Now what we wanted to do is plug in our endpoints. So we want to plug in 0, and that was -0 squared plus 3 times 0. Since we can't see the function on the screen, I'll just go ahead and plug it in. Alright, plugging in f of 0, we get 0. And then remember our other endpoint was 3. So we want to plug that in. And it looks like we get 0 also, right? That's going to be a -9 plus 9 is 0. So we got, and then I'm going to go ahead, well, no, I guess I don't have to. It's already written up here. So our minimum, as you can see, we have 2 of them. Yes, we do. They're the same, 0, 0. And then this is going to be our max up here. Right? So I guess I'll just write it out here. Our absolute maximum, now I'm writing these as points here now, is going to be 3/2. Remember these numbers. I'm going to bring the graph up here in a minute so we can kind of look at this. And then the absolute minimum. And yes, there happens to be 2 of them. So we got 0, 0 and 3, 0. All right. Okay. Well, let's look at the graph. Okay. So here's the graph we're interested in, and we were between 0. So here's x on the x-axis, 0 and 3. Right, between 0 and 3. So you can see where the maximum's occurring. That was at 3/2, which you can see 1.5 here, and then at 9/4, which is 2.25, and then between 0, right, is the same y value, and then right here. And so as you can see, both of we got 2 minimums, absolute minimums that is, and a maximum, absolute max. Alright, so it really helps out to to graph this stuff and look at a graph. So the procedures here are pretty easy. Let's work some more. Alright, this is going to be, I'm going to show the graph first. This is the graph to our the next function here that we're going to find the absolute extreme on. But we're going to be between -1, so you can see the point right here where it intersects, -1 and 2. So as you can see here, we've got a little maximum here and a minimum here. Okay, these are local max and local min, by the way. But we're going to end up finding critical numbers, and it looks to me like at 0, and we'll find another one, I guess somewhere right here at 1. Okay. Anyway, at 0 and 1. But you can see this is going to end up being the max, the absolute max, and the absolute min down here just by looking at the graph. Let's get busy. Alright, so I know I'm always using f of x. It's overrated. Anyway, I use different stuff every now and then. We got 3/2 x squared. Alright, and I said we're on the closed interval between -1 and 2. So we want to find the derivative, f prime of x. Going to be the first thing we do. So we have 3x squared minus, take the 2 out front, 2 is okay, we get 3x. Now we're going to set this equal to 0. And the best thing to do here is I'm going to factor out a 3x. Alright, let's do that. And so we're going to be left with an x minus 1. Hopefully you're up on your algebra. And then I'm going to set each one of these factors equal to 0. So we'll set that equal to 0, and then x minus 1 equal to 0. Get these critical numbers. So the solution to this equation is going to be 0. Right, I'll write x is equal to 0. And the solution to this equation is 1. And I'm going to write x is equal to 1. So since 0 and 1 are in our interval, that's very important, we plug those two numbers in to our original up here. So f of 0, and get that number that looks like a 0, and then we're going to plug in an f of 1 into this, and that's going to be 1 minus 3 halves, and 1 minus 3 halves. What is 1 minus 3 halves? Negative 1/3. Right, plugging 1 directly in. So we got got our critical numbers, plugged them in, got those guys, and I showed those to you on the graph, right? But now we're going to go ahead and plug our endpoints in right here, our -1 and 2 into this up here. So let's try to remember that. So f of, we're plugging in -1 into it, and we get, well, I'll just write it out since we can't see the function up ahead, minus 3 halves, and this is -1 squared. So when we do the math on that guy, we should get -5 halves. Okay, and then when we plug in f of the other one, 2, alright, plugging 2 into this right here, we're going to get 2. Alright, as you can see out of these values here, that, let me just circle them here, this is your smallest, okay, -5 halves, and then your largest is going to be at 2. So we're going to have an absolute maximum at -1, -5 halves. I'm sorry, an absolute minimum at -1, -5 halves, and then an absolute maximum at 2. 2. Right, -1, -5 halves, and then at 2, 2 will be your max. Min, max. Right, min, max, max, min. Okay, you got it. Alright, this is going to be, this will be a good one. So we have h of x is equal to x squared over x squared plus 3, and we're going to be on this interval here between -1 and 1. Between -1 and 1. I just want to glance at the graph. Okay, so here's the graph of that function. Here's -1 and +1. And because, well, we can see this graph's got some symmetry going on, doesn't it? Well, you can see this is going to end up being the minimum, and then we're going to end up with 2 maximums, it looks like. 2 maximums and a minimum right here. So we can just kind of look at that. Okay. Alright, so let's get busy. First thing I'm going to do is I'm going to take the derivative. And that means that we're going to be using the quotient rule. So the derivative of the top is 2x times the bottom, I should say the denominator, minus the numerator times the derivative of the denominator, which happens to be just 2x. So hopefully you guys know how to take derivatives at this point in your math career. Okay. And then of course we square the bottom. Now let's simplify this guy down. So we got h prime of x is equal to, so this is going to be 2x to the third plus 6x minus 2x to the third, it looks like. Yeah, and then that's all over x squared plus 3 squared. So we can cancel some things out. Those guys are going to go away, and I'm going to rewrite this. So we have h prime of x is equal to, we're going to be left with a 6x over x squared plus 3, and that whole thing is squared. Now we want to set this guy equal to 0 and get our critical numbers. Okay, so I'm going to take the numerator and set it equal to 0, and it looks like the only solution to this equation, right, is when x is equal to 0. Okay, so that's going to be the only solution, and down here in the denominator there's no way this could ever be 0 down here. Alright, so then we're going to go back to the original h of x, which I might as well just go ahead and rewrite it, over x squared plus 3. So we're going to take this 0 here and we're going to plug it in. So h of 0, and if we plug that in, we get 0 in the numerator, 3 in the denominator, so 0 over 3 is 0. So we get 0 over 0. Now we're going to go and plug in our endpoints. So our endpoints, if you can remember, was negative 1 and 1. So I'm going to plug negative 1 in. So we got negative 1 squared over negative 1 squared plus 3, and that's going to simplify down to, let's see, 1/4 it looks like. And then if I were to plug in, saving some time here, if I were to plug 1 into this, we get the same thing, right? We get 1/4. Okay, so our absolute max is occurring at negative 1, 1/4, and 1, and 1/4, and the minimum, which is going to be at 0, 0. Right, so I'm just going to write that up here, running out of room. Absolute min, okay, is occurring at 0, 0. And of course we could see that when we looked back at that graph. Alright, I hope that's not too sloppy, and I hope I didn't go too fast for you. Okay, I keep forgetting about Google's graphing capabilities, which is just awesome. Anyway, here's our function, e to the x times sine x, and we're going to be on the closed interval between 0 and pi. So we're going to be right here between 0 and, you can see right up here is my coordinates. Okay, so 0 and pi, which is pi is 3.14, so I'm going to just kind of get close. Actually, that's right there. Right there, it crosses the x-axis. So between 0 and pi. So as you can see, there's going to be an absolute max about right here, as you can see, and it looks like that we're going to end up having two minimums here at 0, and then one right here, it looks like at pi. So let's do the math. Man, I just love this graph. Okay. Alright. I don't know what happened there. Well, it's gone now. Okay, so let's see. Y is equal to e to the x times sine x. Working with some trig functions. And it looks like an exponential function there. We're on the closed interval between 0 and pi. So the first thing I'm going to do is I'm going to take the derivative of this thing. So y prime is equal to, which means we're going to use the product rule. Derivative of the x is e to the x, and then rewrite plus, rewrite e to the x, and the derivative of sine x is cosine x. Okay, check out my video on derivatives. I'll have a link and you can click on that if you forgot how to do this. I'm going to factor out that e to the x. So let's factor e to the x out, and we're left with sine x plus cosine x. And now what we're going to do is, I'm just going to go ahead and set it equal to 0 right there, right? And so we're going to take both of these and set them equal to 0. E to the x, set that equal to 0. Is there anything I can plug in for x here so that we get 0? And no. So no critical numbers going on there. So we can forget that. Set this other factor equal to 0, and that's sine x plus cosine x. So hopefully you're up on your trig. The only thing that's going to get this value that I'm going to be able to plug into here to get this to be 0, and that's going to be 3 pi fourths. Okay, so the sine of 3 pi fourths plus cosine of 3 pi fourths, right? And remember, equals 0. This is going to end up being the square root of 2 over 2, and this is going to be minus the square root of 2 over 2, and so therefore we would get 0. So it looks like 3 pi fourths is going to probably end up being our maximum. And so what we're going to do now is plug in both of our endpoints into the function again. So we have y is equal to, we're plugging in 0 e to the 0 times sine of 0, plugging in one of our endpoints, and that's going to be 1. Sine of 0 is 0, so we get 0 out. And then we plug in e to the pi, and sine of pi, and the sine of pi is also going to end up being 0. So as you can see, we're going to have a minimum at 0, and a maximum up here is going to occur at 3 pi fourths. Okay, so let me write all this stuff down. Looked like I was getting in a big hurry there all of a sudden. We have an absolute maximum, and I'm going to have to scroll down the screen here. In fact, okay, we have a minimum, an absolute min, and I'm actually writing out the points here, at 0, 0, and also one occurred at pi 0, and then we had an absolute maximum occurred at 3 pi fourths. And of course we plug the 3 pi fourths into the original function, and we end up with e to the 3 pi fourths times sine of 3 pi fourths, and sine of 3 pi fourths, which was the square root of 2 over 2. Okay, so we want to keep exact values here. I don't know. Let's go back and look at the graph again. I had so much fun doing that last time. Let's do that. Okay, so remember we had two minimums, and it was at 0, 0, and then the other minimum was at, trying to get my cursor there as close as I can, it's jumping around, at pi 0, okay, and man. And then our absolute maximum occurred right here at 3 pi fourths. So 3 pi fourths on the x-axis, and well, you know, it's right here. I don't know why I think I gotta have it down here so we can see our coordinates up here. But anyway, so right here, I wish they added a feature like you click on max, click on min, click on inflection points, click on roots, and it just kind of like showed up right here, a little deal there. That's a suggestion for Google. Yeah, man. Okay. I think that's all the absolute min max problems I'm going to actually have. If you want to see more calculus problems worked, you need to leave a comment or just give me a call on my phone. Probably not. Better not do that. I don't think I'm going to put my phone number up just yet, even though I do have several Google Voice numbers. But yeah, if you want to see more calculus worked out, I can work any calculus problem in the universe, and that includes fractional calculus too. Does anybody know what fractional calculus is? You know what? I got some time left on this video. I just want to mention fraction calculus. So if you're in a calculus class, you can ask your instructor this. Okay, so I know you just got through learning how to take derivatives and all that kind of stuff. But say, for example, we were taking the derivative of x squared. Well, it turns out that this number up here, okay, we're taking the first derivative. I'm sorry. The first derivative. This is the first derivative. There's second derivatives. For example, f y is equal to x, y prime is equal to 1, y double prime is equal to 0. Well, this is taking a derivative at a time, but it turns out that we can take half derivatives. Yeah, there's actually a way for notation wise up here. Dy over dx, this is like a 1 here, but you could actually say you can take half derivatives. Ask your instructor how to take a half derivative. Yeah, that'll drive him crazy. But actually this number up here can be any real number, and even more generalized, it can actually be any complex number. Half derivatives, 3/4 derivatives, the square root of 2 derivatives. Yeah, and don't get this number mixed up with this number up here, because these are two separate numbers. Anyway, it's known as fractional calculus. After you learn calculus, you need to go try to learning fractional calculus. Yeah.